Neglecting air, you read question 3.1 here.
Neglecting air resistance is the magnitude of the velocity vector impact greater than, less than, or equal to the magnitude of the initial velocity vector.
So they ask you the magnitude of the velocity here at the starting point and the magnitude of the velocity at the landing point, are they the same or not? So the answer is yes. Magnitude is the same, but the direction is different. One is pointing up and one is pointing down. Now, why is it that we say the magnitude of the velocity here and the magnitude of the velocity here is the same? Because we say that there is no air resistance. So there is no loss of energy to overcome the resistance. So the kinetic energy here and the kinetic energy here must be the same. So the magnitude of the velocity here and the magnitude of the velocity here is the same. Now, if it is not the same, that means something is eating up the energy. Something is using up the energy, and then that will be the air resistance. But we say that there is no air resistance. So if there's no air resistance, the magnitude of the velocity here and the magnitude of the velocity here should be the same. It should be the same. Okay, right. There's no loss in energy. That's why it should be the same. Okay, exercise 3.1. Estimate the maximum height in this same problem. So now over here, earlier on, we want to find the range, we want to find the time of flight for this problem. Now we want to find this red line, the height, the height. So you want to find the height, you must use the vertical component. You want to find the range, you must use the horizontal component. So they want the height, I must use the vertical component. So how much is the vertical component? The distance. Okay. So we know that during this maximum height here, the vertical component of the velocity is 0. So I use the velocity equation. Final velocity is the initial velocity minus gt. So at this position, the tallest, the highest point here, the final velocity is 0 because at that position, it is instantaneously at rest. The initial velocity is 40. We are talking about the vertical component, 40. Acceleration due to gravity is minus 10. So from here, we can find the time taken to reach the maximum height. So the time taken to reach the maximum height is 4 seconds. Right. So using this time, using these 4 seconds, I try to calculate the height. So the 4 seconds, try to calculate the height. Substitute into this equation. The displacement, initial velocity times time, minus half gt squared. Initial velocity, the vertical component is 40. Time taken is up here, 4 seconds. Half g is 4.9. Then 4 seconds squared. Right, so calculating, simplifying it is 81.6. But maybe I should have used, because here they use 10 and because actually is one significant figure. This 10 here is actually only one significant figure. So the answer they round off to one significant figure. Okay, round off to one significant figure. Okay, right. So what you need to do is you have to see the vertical component and you relate it with the horizontal one, or you look at the horizontal component, you relate it to the vertical component using the four equations that we have seen here. Using these four equations, right? So you have to relate the vertical and horizontal component. Okay, next question, this one. Can you read 3.4, the quiz?
Suppose you're carrying the ball and running at constant wish to throw the ball and catch it as it comes back down. Neglecting 45 degrees above the horizontal and maintain the same speed. B. Throw the ball straight up in the air and slow down to catch it. Or C. Throw the ball straight up and maintain.
Can you hear me?
Sorry, so just now I think I got disconnected because the internet's raining right now and everything. Can you hear me, sir?
Where is it now? Not sharing. Is it recording?
Yes, it's
Recording.
recording.
It's recording. Okay.
Yeah.
Then let me see here. Okay. I check this. Okay, right. Now, suppose you are carrying a ball and running at constant velocity on ground level. You wish to throw the ball and catch it as it comes back down, neglecting air resistance. Okay, so you want to throw a ball up in the air, okay, and running at the same time. So you want to catch the ball again, not stopping, you continue to run, and you want to catch back the ball. Should you run faster, slower, or maintain the same speed in order to catch the ball? Okay, right. So now you want to catch the ball running at a constant velocity. You are running at a
Okay.
constant velocity, right? And you want to catch back the ball. Okay. Now when the ball leaves your hand, when you throw the ball, when the ball leaves your hand, the ball is moving faster than you or the ball is moving slower than you. Well, it depends on how you throw the ball. Now, if I'm running forward, okay, I'm running forward like that, okay, like this way. I'm running forward with a constant velocity and I throw the ball forward. I can never catch the ball. You know why? You know why? Because let's say if I'm running forward 10 meter per second, I'm running forward 10 meter per second. The ball already possess 10 meter per second because the ball, I'm carrying the ball has 10 meter per second already. Even though it does not, it has not left my hand. I haven't thrown yet. I'm just still running with the ball. The ball already has 10 meter per second because I'm running at 10 meter per second. So when I throw the ball, let's say at 2 meter per second, the ball actually has 12 meter per second. My velocity and the velocity of projection added up. So the ball is actually 12 meter per second. So if I maintain a constant velocity, I will not catch up with the ball. Okay or not? So I shouldn't throw the ball in front. If I throw the ball in front, the ball will move faster than me. And I can never catch up with the ball if I maintain a constant velocity. Okay or not? So far. So in order not to increase the velocity of the ball, in order not to increase the horizontal velocity of the ball, I can only throw the ball upwards. Even though I throw the ball upwards, it has a horizontal velocity of 10 meter per second. Because I'm carrying the ball with me, even though I throw it upwards, it has both an upward component and the horizontal component. The upward component is the velocity that I project it upwards lah, vertically upwards lah. The horizontal component is the velocity which I am running, which I'm running. Because I'm running together with the ball already has 10 meter per second. If I throw in front, it will be more than 10 meter per second. If I throw it upwards also, it will still move in front 10 meter per second. Okay, so what you should do is throw the ball. Okay, I move this over. So in order to catch the ball, you have to throw the ball straight up and maintain the same speed. Okay, it means like that. I throw the ball vertically upwards and I continue to run with the same speed. In this way, the velocity, the horizontal component of the velocity is still the same as me because I didn't throw in front, I throw upwards. So the horizontal component of the ball is the same as me. So I run at the same velocity, the ball also same velocity. Sooner or later when the ball come down, because both of us are moving with the same horizontal component, so when it comes down, I can catch the ball. Okay. However, if I were to project the ball at an angle of 45 degrees, like in the first case, then it is wrong, right? Because if I throw it horizontally, it will possess both my horizontal motion and also the horizontal motion of the projection. So I can never catch up with the ball. Okay, now the third case here, throw the ball up and throw the ball straight up in the air and maintain it. This is what we should do lah. But this one part B, throw the ball straight up and slow down. So if I throw the ball straight up, the ball has the same velocity as me. Then you're still moving forward with the same. And if I slow down, I cannot catch up with the ball anymore. What I should do is I throw up and I continue to run at the same pace. If I continue to run at the same pace, then both of us will move together. So only maintain the same speed and throw upwards. That is the only way to catch the ball. This one actually it is moving. It can be illustrated using the animation. This one can try to look for the animation to illustrate this. Okay, right. Then another quiz. You read this 3.5, a projectile.
As the projectile moves in its parabolic path, where are the velocities and acceleration vectors perpendicular to each other? A, everywhere along the projectile path. B, at the peak of its path. C, nowhere near its path. Or D, not enough information is given.
Okay. Now, for this question, you have to look at the diagram here. The diagram here. As a projectile moves in its parabolic path, this is the parabolic path. Okay, where the velocity and the acceleration, where are the velocity and acceleration vector perpendicular to each other? Okay, now the acceleration is always vertical, always vertical. at every position along the path, it is always vertical. Okay. So if I want the velocity perpendicular to this acceleration, the velocity has to be horizontal only. And if you look at the diagram here, the only position where the velocity is horizontal only is at the maximum height. Is at the maximum height. Because at the maximum height, there is no vertical component of the velocity. It has only horizontal component. The velocity has horizontal component. Okay. And the gravity is vertical. So only in this position at the maximum height is the velocity perpendicular to the acceleration. It's only at the maximum point. Other position, you look at the arrowhead here, right? It is pointing downwards, it's no longer horizontal because you have included a vertical component of the velocity there. So the velocity is no longer 100% horizontal. It has tilted like this because of the vertical velocity. It has tilted. The further you go, they will more tilted down. So after the maximum height, you can never be perpendicular to the gravity anymore. You see, it's always at an angle there. The acceleration and the velocity is always at an angle. It's at an angle. It is only at the maximum height here, the velocity and the acceleration, they are perpendicular to each other. Even during the upward journey, because the ball is traveling this way. So it is not perpendicular to the gravity. It's not perpendicular. It's only at this position, the maximum height. So the answer is it will be perpendicular when it is at the peak. The peak means the highest point here. Here the ball has no vertical component, right? It has only horizontal component. And we know that the gravity is vertical and the velocity only horizontal. So the two of them at this position, they are perpendicular to one another. Okay? So far, any question?